Now we're going to look at the quotient rule. The quotient rule tells you how to differentiate a function of the form f of x divided by g of x. Now we're going to look at the quotient rule, which tells you how to differentiate a quotient of two functions, f of x divided by g of x, something like x squared plus 3 divided by x cubed minus 2x. And here is the statement of the quotient rule. If y equals f of x divided by g of x, then y prime equals g of x, the denominator, times the derivative of the numerator minus the numerator times the derivative of the denominator. Then you divide all of that by the square of the denominator. And again, this assumes that f prime and g prime exist, that the numerator and denominator are each of those functions is differentiable. So now let's look at an example of a derivative that requires the use of the quotient rule. We have y equals x squared plus 3, and that's divided by x cubed minus 2x. So the derivative is going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. And that's all divided by the square of the denominator. Now we need to check to see whether we can simplify this, whether we can factor the numerator and the denominator and cancel anything out. So in order to do that, we're going to first have to expand the numerator and then see if we can factor it. Alright, so let's distribute the 2x across the x cubed minus 2x, and we're going to get x to the fourth minus 4x squared. Then we need to multiply these two expressions together. X squared times 3x squared is 3x to the fourth. We need to change the sign. X squared times minus 2 is negative 2x squared. Change the sign. Three times 3x squared is 9x squared. Change the sign. And 3 times negative 2 is negative 6. We'll change the sign to a plus 6, again because of that minus. And that's all over the square of the quantity x cubed minus 2x. So now we look for any like terms. Well, we have two x to the fourth terms. That'll give us negative x to the fourth. We have three x squared terms, negative 4, 2, and negative 9. I believe those add up to minus 11 x squared. And then we've got the plus 6. And the numerator will not factor, so there is no simplifying that can be done. And we have completed this example. Let's differentiate y equals tangent x. Now that we have the quotient rule, we can find the derivative of any trigonometric function, since each of the trig functions can be expressed in terms of sine and cosine, or one of the other, or both. So in this case, y equals sine x divided by cosine x. That means y prime would be equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. All right. Now, the numerator simplifies a great deal to cosine squared x plus sine squared x. And you'll recognize cosine squared x plus sine squared x as being part of one of the most well-remembered trig identities. That's equal to 1. So we've got 1 divided by cosine squared x, and the reciprocal of cosine is secant x, so this is secant squared x. So now let's try differentiating a function where we have to combine rules. Notice that we have a quotient, so we're going to be using the quotient rule, but the numerator has a product inside of it. So to differentiate this, we're going to use both the quotient rule and the product rule. All right. So what we need first is the denominator, 3x minus 5, and then we need to multiply that by the derivative of the numerator. So we want the first function times the derivative of the second, plus the second function times the derivative of the first. So that would be x squared times the derivative of sine x, which is cosine x, plus the derivative of the first function is 2x, and then multiply that by sine x. Now we need to, we've completed the product rule, and so now we need to go back to the quotient rule. We have the numerator times the derivative of, we have the denominator times the derivative of the numerator. Now we need minus the numerator times the derivative of the denominator, which is 3, and that's going to be all over 3x minus 5 squared. That's a rather messy affair. I don't believe that it will simplify any. I don't think we can get any cancellation, so I'm going to leave it just as it is. All right, and now let's do one more example. Here you're given a function y equals x squared minus 3 divided by x squared minus 4, and we're asked to find all the x values where the following function has a horizontal tangent line. So if there's a horizontal tangent line, that means the slope is equal to 0, which means that y prime is equal to 0. We need to find the derivative, set it equal to 0, and solve. Alright, so we'll go back to the quotient rule. We have the denominator times the derivative of the numerator. So we've got x squared minus 4 times 2x minus the denominator, or the numerator rather, times the derivative of the denominator, and that's going to be all over the square of x squared minus 4. So we set that equal to 0. Well, if a fraction is equal to 0, that means its numerator is equal to 0. So that's really all we're working with here, is setting the numerator equal to 0 and solving. So I'm going to take out a common factor of 2x in the numerator. That'll leave x squared minus 4 minus x squared minus 3 equals 0. Right, I took out the common factor of 2x, and it leaves x squared minus 4 minus x squared minus 3. And again, there's no point in working with the denominator at this stage. So if we simplify this a bit, we get 2x times, let's see, x squared minus x squared would be 0, and then we'll have minus 4 minus a negative 3. I think that's negative 1 equals 0. So that gives us negative 2x equals 0, which of course gives us x equals 0. And I'm just checking to make sure that the original function is defined at x equals 0. If you plug in x equals 0, you get negative 3/4. It is defined. So that's our answer. One thing I do want to note before we leave the quotient rule is that, unlike the product rule, order is important with the quotient rule. The quotient rule has this subtraction in it, and subtraction is not a commutative operation. If you mix up the order of this pair with this pair, you're going to get the wrong answer. So make sure you remember that the numerator of the derivative of quotient is the numerator, rather the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. Make sure you put that in the top of the fraction. Now that we have the quotient rule, we can find the derivatives of all the trig functions. We already knew the derivative of the sine and the cosine. We were able to rewrite the tangent in terms of sine and cosine, and then use the quotient rule to come up with the derivative. The same can be said of the other three trig functions. The cotangent, the secant, and the cosecant, they can all be written in terms of the sine and or cosine, and so their derivatives can be found using the quotient rule. And here are the derivatives. I hope you see a pattern. The derivative of the tangent is the secant squared, but the derivative of the cotangent is negative cosecant squared x. The derivative of the secant is secant x tangent x, and then the derivative of the cosecant is negative cosecant x cotangent x. I always remember that the derivative of any trig function that starts with co has a negative in front. Alright, let's try an example where we differentiate a function involving trigonometric function. So here we've got y equals tangent x secant x. We're going to want to use the product rule. So the derivative is going to be the tangent of x times the derivative of the secant x, which is secant x tangent x, plus secant x times the derivative of the tangent x, which is secant squared x. And there appears to be a common factor of secant x, so I'm going to take that out. And that will leave tangent squared x plus secant squared x.